All right, so just wanted to welcome you to the second part of today's, of the series, AMP Deep Dive for the Security Partner Tech Talks. We have Eric Howard again today. Typically go through a little bit of an intro as far as the partner community and where these slides will be posted afterwards. But I'll put those links into the chat. We're going to run things a little bit differently today. We don't have a very deep panel to answer Q&A during, real time during the session. So what we'll do, still submit your questions into the Q&A panel, and I'll note them. And then about every half hour or so, we'll take a bit of a break and then let Eric answer these live. So go ahead and put them into the Q&A panel, not the chat. And what I will do is just keep up with those going forward. So without any further ado, I will hand it over to Eric as he has quite a bit of content to cover today. Eric, if you're ready, take it away. I'll make you presenter.
Cool. Thank you, Ernest. Can you hear me?
Absolutely.
All right, good. So let me go ahead, since I'm presenter, go ahead and share out my PowerPoint. All right, looks like I'm sharing. Let me go full screen. Okay.
We're good. Thanks.
All right. Thanks, Ernest. So welcome, everyone. Let's get started. I've got a few slides to get through today. I don't know that it'll take the full 3 hours, but hopefully with questions we can get, I think we may be near our full time. I've probably got about 70 or so slides I want to talk to today that are pretty in-depth in content. And but again, I want to make sure I leave room for questions. And as Ernest mentioned, we'll be pausing throughout. So this is kind of our agenda for the day. We spent some time on our last session 2 weeks ago, and if you haven't watched that and listened to that recording, I would recommend you do so. We really kind of approach the entire AMP everywhere architecture and what that means. Today's focus around deployment and deployment scenarios is going to be primarily focused on AMP for networks and AMP for endpoints. And probably the weightier portion of this presentation will deal with AMP for endpoints. There's just a lot more there I think we need to cover and ensure that we're all preparing for success in our deployments, POVs, wherever you're being tasked to roll out AMP for endpoints. So this is the AMP for everywhere architecture. Don't want to go over this in depth. This is, again, just to kind of keep in mind where AMP can be deployed and in what ways, on what form factors, through what security devices, things of that nature. And again, our focus today is on AMP for networks first and then AMP for endpoints. When we say AMP for networks, of course it means the traditional or the known AMP appliance, which is a firepower device that has all of the firepower hardware for acceleration and flow processing, packet flow processing, but it also comes with the malware storage pack as an AMP appliance. And so it bundles together essentially everything you need minus the firepower management console to get AMP up and running in the network. The malware storage pack, the subscription. So if you use those SKUs, that's what you get. But if you have firepower, the application or services, as we call them, running anywhere else, an ISR, an ASA, if you have it running alongside, in FTD, you have the ability to enable AMP for networks, and it functions the same, whether it's on ASA, ISR, inside of FTD, on the traditional firepower appliance used for IPS deployments, or the AMP appliance. The software works the same. And so everything I show you, and even in virtual, I'm sorry, I did not include an item here for firepower virtual. But again, the application works the same. And so all the things that I show you will apply across platforms. There may be differences in throughput, and of course there are going to be differences in speed capabilities, but all of the things that relate to AMP will work the same. So if we're looking at the inspection path as we insert a sensor in the network, where we handle packets from a firepower perspective, this is where you begin to tune and configure AMP capabilities. In the inspection path, you're going to see AMP come up. AMP will be utilized, I should say, in the rule processing scenario from an NGFW perspective. So you have to create at least one or two baseline rules, right, for NGFW so that we can pick a file policy to layer against the traffic coming through us. And if the NGFW has rules that will keep us from even seeing AMP because there's no file policy tied to it, we have to remember and consider that. But there are other things that will also prevent AMP from seeing traffic and using a file policy for inspection of the content in that traffic. The first is that if you've chosen to just use a trust rule. A trust rule in the NGFW part of your policy, because we have to consider that piece, means that I don't want to send this traffic to any of the other inspection capabilities, be it AMP, IPS, URL, DNS blacklist, doesn't matter. I don't want to use any of those inspection capabilities. So a trust rule will kick the traffic out of the inspection path quickly, and we won't get to a file policy. If my NGFW policy has a block very early on, let's say based on some security intelligence information or geolocation data or something like that, some of the lower level baseline inspection points for a firewall, that means that traffic will be blocked. It will be dropped to the floor, and the inspection path will not continue. I won't see traffic for file policy. So ordering rules in regards to the NGFW, the upfront lift the packet off the wire, figure out whether it is IP version 4, IP version 6, things of that nature, you have to consider orders there, because you won't get a file policy or, as you can see, a network discovery policy or an intrusion policy that can be used until you reach in the NGFW or access control policy, as we call it in the FMC. You won't be able to add on those other points of inspection until you have a rule that is set to allow on the NGFW's perspective or the access control's perspective. Once I have a rule that says, okay, this traffic is allowed, it goes through IP reputation, it goes through any other application blocks that would normally be considered, it has made its way past all of those rules 1, 2, and 3. We finally hit a rule where this traffic is allowed. Now I have the ability to begin to layer on additional inspection, which includes AMP in that inspection path. So network discovery policy comes first every time. The file policy is next when we look at the order of inspection through the engine on either the appliances, as I mentioned, or firepower services deployed on ASA, ISR, or virtual. File policy comes after network discovery. That's because network discovery is going to give us insight needed to know where the protocols are in the traffic that we can actually use to inspect for files. It'll tell me where POP3 and IMAP are. It will tell me where FTP is. It will tell me where SMTP traffic and NetBIOS traffic is. And so I have to have network discovery in place and working properly to be able to get at the files needed that then can use a file policy to apply inspection against it. Notice that this says file policy, and the little note next to it says that both files and malware blocked. That's because the file policy can be used just to block files of a certain file type, and I discussed this a little bit 2 weeks ago, even if I don't have a malware license. but it is still configured in the file policy. And just to continue on through this, once we've triggered the file policy as a part of the inspection path, if there is nothing that would cause a block there, the next order of action is the intrusion policy. So this is how packets are seen by Firepower Services, where the file policy comes into play in the inspection path, and how you actually get traffic up to the file policy is going to be determined by your access control policy at a lower layer. So let's get into the actual file policy order of processing. The first thing that we do when we get traffic to the file policy and are able to dig into the protocols that carry files, we're going to have to figure out whether the file is above or within our file size limits. There are some options here. There are, of course, some defaults built in, but there are options here on the file size limit for calculation of SHA-256 and capturing files. Those things are configurable, but just take note that if you configure the AMP Networks system, be it virtual or services or appliance, if you configure them to process larger files at the maximum values, you are going to hit some limits. You will begin to experience performance limitations because it's just going to incur more work for larger files to generate the hash and do all the other work you're going to see in a moment. But again, the first thing we'll see is, does this file go beyond the file size limit? If it does, we will stop capturing files. This is not the file store piece. This is the stop capturing files. Stop buffering files in your processing tables and building the SHA-256 hash. We will not proceed if we are able to ascertain that we see a file that's larger than the file size configured in policy. If the file size is within limits, we continue until we see the end of file. So we do look for an EOF marker in every file transaction. We determine whether we've seen what we believe to be the end of a file, so that when we have the entire file, we can properly calculate the hash. If we see the EOF, that's important because that's what we hold if we are going to ever drop traffic, as you see in 2 steps away from calculating the hash. So file scene, yes. Entire file scene, yes. Calculate the hash, generate the SHA, and let's send that up to the cloud through the FMC so that I can figure out whether this is malicious or not. If I have the last packet and I am waiting on a response, then I will actually drop the last packet in my order of packet processing to call systems to continue to request. The receiving host will send out over the normal TCP mechanisms, right? I need this last part of the packet stream retransmitted to me. It was lost in transmission. We do that because we are waiting on the answer to come back from either the local cache or the AMP cloud. While we're waiting, that retransmission is going to give us the ability to determine what we need to do with the file if it is seen as malware. While retransmits are occurring, if the answer comes back that this file is malware and our policy is set to block, we will not only generate an event, we will actually drop the last bit of that traffic stream or that file, the bits that are being retransmitted, of course, log an event. And then from there, what should end up happening is that what gets pulled down to the receiving host is a file that should be somewhat corrupted and unusable on that system. And it, depending upon the application used, it might even remove the file from temp if it is something that has not seen an EOF marker, if it's not a full and a complete download. If the file is not malware, then we're going to assess whether it is considered clean or unknown. If it is considered clean, we do not process any further. We stop processing, we mark the disposition as clean, and log that particular file transfer event, but we don't add it as a malware flag. We don't add the malware flag to that event log in the database. If the file is not clean, it's not considered malicious, then it lives in that state that we call unknown. What I do with unknown files are based on policy also. One of the options for unknowns, and it's the one that we recommend, is that you capture them. You actually store the file locally on the system processing traffic so that I can then use another component to assess behavior and gather insight so that I can then determine actions against that unknown file. So here what we've seen again is file being lifted off the wire, determining whether it meets our file size limitations, capturing a file and causing the sending system to retransmit the last bits of the file while we're waiting on a response back from either local cache on disposition or the AMP cloud. And then once we have a response back, that allows us to take our file policy and say, we'll block this because it's deemed malware. We will send it on for submit no further processing because it's deemed clean, or we need to take a few more steps if it's considered unknown. I have another page that talks about what we can do with unknown coming up in just a moment. So our order of processing for inspection within a single object, a single file. The first thing is that if it's an executable file, I generate what's called a Spiro hash or Spiro feature print. I addressed this 2 weeks ago on our previous call. This is the machine learning engine. Machine learning engine is something that works against portable executable files. So it has to be a Windows executable. And we are able to do some static heuristics against that file while we're processing the stream. So essentially, I can grab the PE header and grab tons of attribute data, build a feature print, and then submit that feature print to the cloud. But again, that's limited to executable files. And so this is something that you can feel comfortable turning on, because you're not going to see tons of executables, tons of EXEs flying across the network in most of our inspection points. And getting the insight into, one, that executables were being seen, submitted across the network, one is good insight and context to have. But two, to be able to gather insight into the construction of that EXE and use the behavior analysis of machine learning engines in the cloud is great extra data also to help determine a disposition. The second thing I can do with a single object that matches in a file policy rule, so a file that matches in a file policy rule, is this thing called local malware analysis. This is newer. Local malware analysis is one of the newer components to building a file policy rule, and it allows you to use a local malware inspection engine. So the AMP for Networks component uses a slimmed down ClamAV install that will examine file composition and properties, and it'll take apart, as an example, a PDF and give you a compositional report of a PDF, an Office document, to show you what embedded objects are there, what do those object streams look like, can it be malware based upon the data that we're able to see in the file and its structure and file properties. And that local malware analysis will also give you the ability to block. I'll bring that up. I'll come back to that in a moment. The third thing I can do on a third action I can take on a single object that matches a file rule in my file policy is dynamic analysis. So Spiro analysis, matching against portable executables and building a feature print, Local malware analysis, right? Taking a local inspection engine and examining a file to figure out whether it's something that could even possibly be malware and host executable content, examine file structure. Third is dynamic analysis. Dynamic analysis is traditionally called sandboxing in the industry. We, of course, as I mentioned, use ThreatGrid on the back end for our sandbox, but dynamic analysis takes files submitted either to our dynamic analysis or ThreatGrid cloud or an on-premise appliance. And this can be submitted without having to store the file on a box. We can submit files that are not stored on the appliance up for dynamic analysis, but we do it if it's unknown. As mentioned on the previous slide, if it's not malware, it's not clean, it's considered unknown, then I can bring in dynamic analysis. Dynamic analysis retrieves a threat score at the end of execution. So it gives us execution summary, behavior indicators, what DNS traffic has been seen, what HTTP traffic, what raw IP streams do we have that don't match, the DNS and HTTP protocols, what artifacts are seen when this file is opened or executed after we examine the sandbox for state changes at the end of execution. So once we've pulled in the dynamic analysis report, we can actually do some scoring against that. So I've got more than just a hash that allows me to determine whether I want to block files or not. I can use Spiro data, so machine learning against portable executable files, local malware analysis, which can give me the ability to drop traffic based upon local signatures that I have, or dynamic analysis. If the threat score is high enough, I can use that to determine that I want to block a file, even if I don't have compositional data from local malware analysis, execution, behavior analysis from my machine learning engine called Spiro, or no file hash. So back to my malware and file policy order of processing. Earlier, on 2 slides back, I said if we get past something being called malware, past something being deemed clean, it's in this state of unknown. What can I do with an unknown file? Well, in addition to logging its transit across the network, I can take that unknown file and submit it up for dynamic analysis or ThreatGrid as is seen on this slide. What do those steps look like? First thing, one, is it a file archive? If it is, I need to begin to rip this apart. By default, I will go 2 layers deep. You can configure this to go, forgive me, but it just slipped my mind. I think the maximum is 4 layers deep to unwrap an archive. Once I get down to figure out whether it is, one, an inspectable archive that can be unwrapped to get to the proper content, we'll figure out whether we need to actually store those sub-files. And if I do, go about the work of capturing a file there. Again, Spiro, as mentioned before, which can give me a hash, local malware analysis, which can check the structure of a file and give me information back and determine whether it can even be considered something that can host malware because of the file composition and structure. If I go through all of those particular points, and dynamic analysis is the last point in my path of protection, this file gets submitted from the, excuse me, from the FMC up to the ThreatGrid cloud, so that the ThreatGrid, or on-premise appliance, so that execution state is determined, behavior indicators are retrieved, and a threat score comes back. There's one other option I didn't really pull out earlier. It's called capacity handling. It is one action item that you can configure. Capacity handling looks at the busyness of a box and the connections to the cloud to determine whether we're seeing something that could be performance related on file submissions, right? If I'm seeing so many transactions to the cloud, so many files being submitted, and it's causing the box to slow down in its order of processing, capacity handling will tell me to back off for a moment. Just hold on to those files you would submit. Let's let the box settle itself. And once we see lower CPU and better response times to and from the cloud for all of our submissions, we'll go back to submitting those files back up. That's just an offhand, not offhand, an off to the side option that can be configured if there are performance issues being seen. But again, once I have the threat score back, I then can figure out whether I need to file a full file event, something that has a threat score high enough to block files, or at the end it's still deemed unknown because my threat score is not high enough. By default, the system does not block based on threat scores. You have to tune this as a file policy option under the Advanced tab. There are ranges. I've included them in this slide deck in a hidden slide, so it won't come up in the presentation, but it will be there for those of you that download the presentation after. There are ranges that can be chosen to determine when you want to take a threat score and use that as the mechanism to block files. The category names are very high, high, medium, and low for those ranges. The recommendation is if you are going to take a threat score range to determine when to block a file that has no set composition or disposition in the AMP cloud, no malware composition through local malware analysis, that you use that for very high only. So there was something I kind of skipped over because I knew this slide was coming on our previous slide. As a part of determining submission to the cloud and local malware analysis, there is one component called the pre-classification engine. This is the piece that I mentioned that is the slimmed down CLAM install on the AMP for networks that will look at how a file is structured, look at object streams, and determine whether it's something that could even be malicious because of how the file is built. This pre-classifier takes in files, a part of the stream you saw earlier, and gives us, of course, a composition report. I want that data, but based upon what is seen, if there is no chance at all for a file to be considered malware because the object streams don't work properly, it does not have any embedded objects that are executable or can host executable content, no macros in an Office document, things like that, that's considered a normal file. And even if you have a file policy set for submitting unknowns to the dynamic analysis cloud, if the pre-classification engine determines that there is nothing here that would cause this to be malware, it will not submit that file. But if it is something that could be suspect, then it will be submitted to the cloud. So I have to go through pre-classification first to determine whether this is something that will even, one, work in the dynamic analysis sandbox. Is the file corrupted? Is it packed properly? And two, is it structured in such a way that it could even host malware inside of the file? So in order to make pre-classification really accurate, we do embed signatures. There is what we consider a very high fidelity, high confidence signature set embedded in the AMP for Networks sensor implementation. It has about 70,000 signatures that ship with the embedded AMP local malware analysis engine, or slimmed down CLAM AV, that will be used to examine structure, file contents, embedded streams, macros, things of that nature. If we see an eligible file, yes, we can block it based on simply on pre-classification. No need to even send it up to the cloud. But notice that if I have this LMA or local malware analysis piece enabled, I'm going to need signature updates. The way that works is the FMC will notice that you tick that box in the file policy and phone home every 30 minutes to our support sites to pull in updated signatures for the local malware analysis engine. It will then make that available to the sensor so that you can have those updated SIGs available, and it can also be used to generate cloud recall or retrospective action. So how do I order my file policy rules? If we went kind of down into a file policy, and then we went another layer down into the objects and the way they're handled by a file policy, let's come back up a couple layers and look at ordering file policy rules. There are 4 actions that you can take on a file policy rule. An option choosing between 4 actions. One is that I can block files. If I choose to block files, these rules are very specific to just determining the type of file. Is it a PDF? Is it a Word document? Is it a Windows executable? Things of that nature. And if it is, we will block that file at the point of identifying the file type and not continue on to any subsequent action. If you do this, you can configure, if any of the blocks are set, you can configure a reset to be sent to the systems involved in the communications so that the systems are not sitting there holding half-open, TCP sessions and things like that. The next action as an option would be to block malware. So not just block a file type, but also determine whether it is malware. This comes from querying the AMP Cloud and determining whether the file traversing a network actually represents a real threat. And if so, drop that, of course, log an event and have extra data. The third option could be to perform a malware cloud lookup. This simply does gets disposition, but does not block a file, even if the disposition comes back as malicious or malware. And then the last option would be to detect the file. This just logs all files transiting the network, even file types that may never host malware themselves, but we may want information that this is flying across the network, do some file tracking, give us the hash of the file, and use that to report against for file transit, just to get some trajectory of a file in the network. This is the actual order of how a file's policy is evaluated. You can put the rules in any order you like as you're creating a file policy. My recommendation is that you group them based upon this order of operations, because this is how the engine works. It's just easier to keep in mind that these are all my block rules. These are going to be hit first. These are my block malware rules. Those would be hit second. And this is malware cloud lookup. Those would be hit third. And then lastly, any simple detect a file rule. And so as you're building your file policy, I recommend this order because it keeps things at eye level in line with the way the actual file policy is expressed in the engine for blocking, determining malware, and just logging files. So in addition to file order, you have you have something called options. And I mentioned them, I've explained them a little earlier, right? I talked about Spiro, I talked about dynamic analysis, capacity handling, LMA or local malware analysis. I mentioned the ability to reset connections. And I also talked about storing files on a malware storage pack or local to a system. If we choose options to go with an action, this is how they lay out for us. Meaning if I choose Spiro analysis for Windows executables, one, can I just block files? No, that's not going to give me the ability to just tie to a block file, because remember, block file type is the first thing that we do. The moment I determine it's an executable file, I am not going to get the information to generate the Spiro fingerprint or feature print. Block malware capable. Yes, because one of the feature prints or fingerprints used to determine malware could be Spiro analysis. Detect files capable. No, Spiro analysis is not going to be chained or will not work with an option to just detect files, because Spiro is intentionally built to help determine or assess whether a file is malware or not. And then the third one is malware cloud lookup capable. Yes, if I have Spiro as an option enabled, those executable files can be submitted to the cloud. That's the way this table works. That's how you would understand the options and how they are coupled with actions and how they would then work in a policy. So let's go through one more. Let's look at local malware analysis, right? Local malware analysis, again, is a specific component to help assess whether a file seen is malware. So if I'm going to just block a file based on file type, my order of file policy processing tells me that the file type blocking is the first thing that I see, so that it will never get to the local malware analysis engine, so they won't work together. Block malware capable? Absolutely. Detect files capable? No, because local malware analysis is going to work on files to determine whether they're accessible, to assess whether they're malware or could be malware. Malware cloud lookup capable? Yes, because this ties into the actions of assessing a file, properties, composition, etc., so that we can then submit it up for malware analysis in a sandbox to get an answer back. That's how this table works. Hopefully that makes sense, but I want to make sure that you had an understanding of actions, which are block files, block malware, malware cloud lookup, and detect files, versus the option radio buttons in a file policy rule that can be turned on alongside an action. We try to do a good job of ensuring if you choose an action that appropriate options are only available, and so that when you're choosing an action, you can only choose the options that would work alongside that in the UI. But if there are any questions as to why, hopefully this helps to explain why some options are only available with some actions. So let's come back up another level on AMP for networks. So we've got a file policy deployed. We've got our options and actions set. We've got file types that are matching and events that are being generated against our rules. When does AMP actually block malware based on other policies I have? So I don't need to go back into the network traffic scenario. We did a deep dive on that a few moments ago. Let's look at how the engine, the entire engine would then give us file data. If the network traffic is dropped by a file policy, of course, I'll have traffic blocked. I'll have file inspection events and data there. I will not get any data from the intrusion inspection engine. So the intrusion prevention engine won't have anything to tell me, because if you remember the order of operations earlier, file policy comes before intrusion policy. Network discovery will have information. We will have information because network discovery is going to be key to actually assessing whether we can get to files in the traffic stream. If in my network traffic, my file policy doesn't match on anything in a particular stream, but the intrusion policy does, I'll end up with the end event of traffic gets blocked, so prevention can take place. I'll have file inspection data and events. I'll even have file trajectory information. I'll have intrusion information and events. And then, of course, I'll have network discovery. If network traffic has made its way to this inspection part, it's passed by intrusion and by file policies. Of course, I'll have all the data you see. Traffic will not only be allowed to the destination that we're sitting in front of to protect, but also the file inspection policy will cause us to have information and event data. And if I'm just detecting files, I'll have that file trajectory even for unknowns available. Intrusion inspection, that will, of course, work against the traffic. If there are no events that fire, we won't have intrusion event data, but we will use the intrusion event policy to inspect against traffic. And then, of course, again, network discovery has to be on in order to even give us good insight and give us information into the traffic we're going to be looking at. No policies against that. Traffic would be allowed. network discovery would be seen, we would not have anything from intrusion or from file inspection. So when does AMP actually block? Before intrusion, after network discovery, and a file policy has to be configured with to either block files, block malware. All right, we're at about 30 minutes or so, and we're getting ready to go into AMP for endpoint, so this might be a good time to take a quick break and see if we got any questions.
So as of right now, we do not have any questions. None have come into the Q&A panel.
Okay, I'll give it about 60 seconds and see if anyone wants to ask any before I go into AMP for endpoints.
I believe I might have heard someone just raise their hand. Just a moment. No?
Nope, we're good.
I believe we are good for the moment.
Okay, thanks, Ernest. If you have AMP for networks questions that come up while I'm going through AMP for endpoints, please put them in the Q&A. We'll take another break in about 30 minutes and come back to questions, and I can cover both at that time, AMP for networks and AMP for endpoint. So AMP for endpoints, right, deployed across Windows systems, not just traditional desktops, but also servers are optional there. Android mobile, no iOS support in case anyone was wondering. Nothing to announce there, nothing at all available. Virtual. Virtual there does not mean an endpoint component or connector that is built to protect the hypervisor. Simply means you can install it in virtual environments inside of the guest operating system and get visibility, because at that layer inside the guest operating system, it just looks like a normal host to us. And so whether that would be a client or a server, doesn't matter. You can deploy us there, very lightweight, of course, and thin and not impactful heavily against system resources. There is a Mac OS client, and then there is a client for Linux. I mentioned this a couple of weeks ago, so I won't go too far into it right now, but you have the ability to deploy AMP for endpoints through the AMP enabler inside of AnyConnect, as long as you have AnyConnect version 4.1 or later. All right. So a simple framework for how we're going to cover this. I'm going to focus primarily on policy, not a lot on deployment. Meaning I won't dig into the weightiness of deploying through group policy objects or SCCM or anything like that. There is available to everyone through either the support site. It should be up on the Partner Central pages. It also is available if you have an AMP Cloud account. You can pull down a guide that we call the Deployment Strategy Guide. And hopefully everyone that is working with AMP for endpoints has seen this guide. It lays out for you cleanly and clearly the steps for installing through SCCM, and those steps can be then transferred across to other tools that are used for software management and system installs, again, be it CASE or EPO, and of course, as I mentioned, through group policy objects and things like that. The key components to an endpoint install are, one, we're going to have some level of connectivity to the AMP for endpoints web server. The way we typically recommend you install is that you generate a policy and you pull down what's called a redistributable package. So this redistributable package has contained within it, if it's Windows redistributable package, it will have both the 32 and 64-bit installers and the policy declarations that would go alongside with that Windows install. If you're using something like Jasper to manage your Mac, then you would pull down the Mac installer, which would also include its policy XML in one package, and then use that to push over to Jasper to push out software to the Macs that are being where you're deploying to for endpoints. In either scenario, you're going to host this somewhere inside of your systems management software on a file share somewhere where it's accessible, and then the systems will then be able to reach that local package and proceed about the work of install. But in order to get a policy ready, in order to have that installer ready and packaged up, we've got to get a policy set and ready to go. In building a policy, there are two things that are the most important things you have to remember in building app for endpoints policy. One is I have to ensure connectivity. Cloud connectivity is required for updated protection. Your connectors, every connector is going to need to be able to talk to the cloud to perform initial registration at install so that we get the unique GUID for that particular host so that it is registered into the right, the right federated login in the cloud so that it is put into the proper group under your cloud login and a whole host of things, right, so that it receives, so that it can kick off its initial scan and send that data back up. Cloud connectivity is required for the initial install and for updated protection. What does that mean? That means, of course, we're going to send event data to the cloud, but as new dispositions are made available in the cloud, those are going to be referenced by every connector. So I'm going to need to be able to talk to the cloud no matter where I am to be able to do a malware cloud lookup from every connector in the environment. The issues around that could be proxy servers, and I got a whole section on proxies that we'll get into in a moment. Firewall rules. Are we blocking the traffic necessary? Because we're in environments that are just highly locked down and very tight, and we can't reach the cloud on the ports we need. And then SSL decryption. Let me just say up front now, if you are dealing with SSL decryption for your connectors to reach the cloud, it will not work. The second component we've got to consider are exclusions. Exclusions are built to help us coexist, meaning there are typically going to be other tools installed that will work in a similar fashion, right? You're going to, in most scenarios, there's going to be another AV or NAV living on that host, and having another tool installed that can have similar functions in terms of examining file I/O could be problematic. And exclusions are built to help us coexist with AV, other security tools that process file I/O, and we need to make sure our exclusions are built to ignore the other software installed. So let's say it's endpoint AV like Kaspersky or Symantec. There are going to be exclusions you need to configure for some, but there'll be others that already have it baked in. You're going to also need to look at those other tools and say, exclude the app for endpoints install directories from your inspection. Don't dig into their quarantine. Do not monitor their processes. Do not shut down the task tray icon if it's running, but leave the app install alone so that you can work in a mode we used to call companion mode. You can work alongside each other. Exclusions are also going to be useful if there are directories or files or file types that are just heavy on transaction I/O, and it causes the connector to bring about some performance implications. We may need to begin to build exclusions. I've got some things around that. We'll go deeper on both connectivity and exclusions in just a moment. That said, while exclusions do help us to live alongside other security tools, there are some tools that we do not coexist well with today. And it's primarily related to the notion of driver altitude. So when software such as, AV or AMP for endpoints or tools like you see listed here that are concerned with file I/O, are installed, they register with the Windows subsystem. And everything that registers at a certain driver altitude or level in conversation with the kernel. And if there is a conflict in driver altitude, you will get competing processes that cannot work alongside each other. And what ends up having to happen is that one system or another will need to change its altitude on a host so that it can work alongside existing software. And what we found in our testing and in deployments is that if customers have Carbon Black or the old Zone Alarm stuff or even AppGuard installed, we will have issues installing there. And if they try to come behind us, we're installed first, there will be installation issues. And so you have to, at that point, it's a call into TAC to get some configuration assistance and advice on getting the altitude set differently for one of the applications being installed. And typically it'll be which one is being installed last. You'll have to talk to that vendor if it's the other piece of software. If it's for endpoints coming on after one of the other applications we're colliding with, then work with us through TAC, who'll get it escalated, and we can figure out how we can change the driver altitude and to where for that particular endpoint install. But a key thing, again, there are some tools that we just don't coexist well with, and we need to apply some configuration assistance there. So, policy. How do we get a policy set so that we can move forward getting an installer package ready to go and pushed out? When you first log into AMP for Endpoints, your Cloud Console login, you are presented with what we call a quick start guide. It'll walk you through some setup. And for most people, this is good enough. It was really written for direct to customers who need to be able to quickly get a policy up and going. For you all and for this session, I'm going to tell you who are typically involved in full deployments, typically involved in full deployment to ignore the quick start guide. You're going to jump straight into a few things that I'll recommend to you to get started on building a policy. If you're helping a customer, I want you to do a couple things. After you've ignored the quick start guide, first thing we're going to do is let's go into outbreak control. There's a section there called custom detections. It's typically called quick SCD, simple custom detections. And the issue with quick SCD is that nobody really knows what it means. If you rename it for your customers, you're going to help them to start. Name it something like quarantine list. This is where we're going to put in our custom detections to go forward, right? This is something that makes sense. These are the files that I'm quarantining or blocking or removing off of a host. That's where I put the hash. It registers. It makes sense there. The next thing you're going to do is build an application block list. The application block list should also be named something quite useful to you and to a customer. Step 3, let's get into policy. I go through step 2, the SCD, the custom detections and application block list because they're referenced by the actual policy settings themselves. Policy settings, administrative stuff. So there are some things that are going to be set by default to enabled and others that are not. When you're configuring policy for endpoints, anything that is not in the default state, we will call your attention to. We call your attention to it by bringing up this blue information icon off to the side of an item where you changed the default state. Notice if there is a change to any default state on any item under a section in the policy, the larger section, so notice administrative features itself has an item there saying, essentially to inform, you've made changes to the default state to one or more options under this section. We do recommend you turn on usernames in event. It's not on by default, and it is primarily related to privacy. We do have some customers that don't want usernames sent to our cloud. If it's something that can be configured, do so immediately. It adds to the data, adds to the context, adds to the richness of information. Send file name and path info is on by default. That's just a key thing that we need to have or would like to have. My recommendation is that you set heartbeat interval to 15 minutes. The default is 30, which is not bad, but it is something that you're going to want to happen quicker, a sync to the cloud. You're going to want that to happen quicker, especially while you're in this phase of initial setup and making policy changes and tuning some items. You're going to want to make that happen faster. So heartbeat interval. The heartbeat interval harkens back to our session 2 weeks ago. I mentioned this notion of a protocol we call ping 2, where every connector phones into the AMP cloud based on an interval, this heartbeat interval, and essentially inquires to any updates to policy, any changes in configuration, things of that nature. The connector log level, leaving that as the default is typically fine. You're not going to move that or the tray log level up to a debug unless we're working with TAC to troubleshoot a very sticky or problematic install. Automated crash dump uploads. Yes, that's something that is on by default. And what it takes is if there is an issue where FireAmp does crash or core out on a system, then we will take that core file or that crash dump and attach it to the federated login. So it's not something that gets sent to TAC automatically, but it does get pushed into the AMP cloud under your login automatically, so that if a case ever gets escalated to tier 3, something TAC can't resolve, we've got some information and insight to that host. We don't have to keep going back and forth with customers. Okay, enable this, now send me a dump. Enable this, now send me a dump. We've got information that hopefully is very useful right away. Connector protection. It's not on by default. I recommend you turn it on. Connector protection essentially helps to lock in the install. Most users are going to run with administrator level privileges in many environments. And quite often, if they see a new application installed, they may try to uninstall it, or they may try to some other way try to muck with that application. I would say enable connector protection, add a password against that essentially locks out users from easily being able to disable, turn off the protector engine on the endpoint, disable the service, uninstall it, bother the install directories, things of that nature. So I would recommend you turn that on. Let's go to the client user interface. So administrative is where we were. The next section down is client user interface. The client user interface is typically a part of the install, meaning there's going to be a task tray icon that will give you notifications that will say we saw a file and the disposition was malware. This file name is malicious. We blocked it, things of that nature. Or if it's tied to, if you have device flow correlation enabled, a connection to a particular IP address a connection to a particular IP address was to a suspicious host or suspect host, things like that. You can turn off those notifications. You don't have to enable the user interface to on installs. It can be completely hidden, which is actually the most common way that the UI is installed. But again, it's an option. Start the client user interface, cloud notifications. This is the noisy stuff, right? Just the fact that we're connected and we see, X million number of new hosts or hosts connected to the cloud right now for protection against, 400 million strings of malware. Those kind of simple notifications are typically not something that you're going to enable. verbose notifications. We don't want to be noisy. We don't want to be have extemporaneous notifications popping up in the corner of a system, so we'll leave that off. It is a default state. Hide cataloging notification, hide file notification, hide network notification. Notice that they are not on by default. Though it is the most common method of deployment, having a hidden install, no task tray, the task tray icon there, but no pop-ups, it is still not on by default. And so I do recommend that even if you leave the task tray icon, which is the start client user interface, on, you still turn off the notifications that would pop up. The File tab. I skipped over proxy because I've got a whole section on proxy coming. Proxy was the next one down here. I've skipped over that because I have a whole section coming around proxy. So I moved from the General tab to the File tab. So let's look at what we changed. The default mode is going to be Protect mode. That's not where we want to start. In a deployment, we want to start in Audit mode. Audit mode doesn't lose any product capabilities. It just removes the block function. So I will still alert. I'll still have data. I'll still have full device trajectory insight and information, but I will not be able to block a file or stop a connection to a suspicious host. But again, it is the place we recommend you start in audit mode to get a feel for the deployment, the event data and types that we'll have to deal with, make sure the customers are comfortable and settled and set. The maximum scan file size, I recommend you change that. The default is 5 megabytes. The same is for maximum archive scan file size. I recommend you bump it up. Bumping it up to 10 megabytes is not very impactful to performance. You can go as high as 50, but if you go as high as 50, you are going to see performance impact on larger applications. There shouldn't be many, but there's certainly going to be some that have large file sizes. And we need to consider that. 10 megabytes is going to give you coverage across well over 95% of the files seen on any particular host, well over. The number's probably actually closer to 98% of the files on a host. There are just not that many single applications or executables or files that are going to be, that could host malware that are going to be much larger. If there are other things you might need to consider. You can, again, bump it up to 50 megabytes. 10 is the recommendation for sizing and performance and building the two in together.
Hey, Eric.
Yes.
Can we take a quick break? There's just a couple quick questions that might be a good time.
Absolutely. We're about another half hour in, so we can do that.
Okay, so we're backing up a bit, the AMP for networks.
Yep.
The question is, when block malware is enabled, users complain about slow file downloads. What can be done about this?
Well, it's kind of the knock-on effect of blocking malware because of the way we actually implement that block, right? So we do hold the last bit of a file and force retransmit. And if we make the decision that it is malware and we've decided we're not going to let that file make its way on, you've got to either, one, try to get the connection reset so that it shuts down. So reset connection might be an option. Or you wait for the timeout, which does then appear to be slowness. But the truth of the matter is that we're trying to enforce protection if we've chosen to block malware. Performance is is something we'd have to really kind of deal with, in a call or conversation explaining this is why it was slow. We were blocking this file. We deemed it to be malicious if you're not going to be able to reset those connections.
Okay, thanks. Bill, I hope that answered your question. The next one is in regards to threat grid analysis. So the question is, if a busy IPS or ASA always exceeds the submission limits for the day, would threat grid analysis always be 24 hours behind, and also could some of the submissions possibly be dropped? So say like on the 5555, it has a default limit of 500 submissions to threat grid. Say the first one is uploaded at 1 o'clock, the next one is uploaded, or file 500 is uploaded at 6 o'clock. Is there going to be anything that happens with those files? Will they be delayed or will they be dropped?
Yeah, it will be delayed. It will be delayed. We'll hold it as long as we can, and typically we should be okay with getting that file back up to the cloud later. But the short answer is it will be delayed. I don't think I've seen a scenario yet where the file submission was completely dropped and ignored. But I have seen where there is a delay. And what we do recommend in that case and scenario is that we offer the customer the option to purchase the upgrade for submission. So there is an upgrade path for submissions that take you beyond the built-in default. Be it 100 on a small amp for endpoints or 500 on one of the mid-size sensors. There is an option to add an upgrade across the board to any submission limits for the built-in threat grid component that can kind of alleviate some of that daily submission pain they may be feeling.
Okay. So just to clarify, after that, if the limit is 500, is 501 dropped, or is it just delayed until the next day?
Delayed. It is delayed by default. Okay. Delayed.
Okay.
I don't. And if I didn't make it clear, I'm sorry. I don't think I've seen a scenario where it has been dropped yet. I have seen delays. That's expected because of the back off command or response that they get from the threat grid cloud. There's a back off response that comes back, and you just have to wait. And so it will be delayed.
Okay. And then Ryan followed up. Are older files submitted first to threat grid? My assumption there is yes.
Yes, the queue remains the same, and so the first files in the queue would be the ones that get sent once we have the ability to submit again.
Okay. And unfortunately, Bill had stepped away when you answered his question, so I'll try to give a quick synopsis. Basically, the issue with blocking the malware is because it's waiting for that disposition. So if performance is an issue, then that's just kind of, unfortunately, and again, paraphrasing here, a bit of the nature of the beast, if you want to follow up from that.
Right. And so, we typically, we have by default about a 2-second max delay for the time we'll wait for the cloud to come back to us. If we, not receive the response, we'll let the file continue on, even if it is malware, and we later find that out. Retrospection is the way we try to cover that in any future instances of download. If within that 2 seconds we get the response back and it is malware, yes, you're either going to have to reset. You're going to have to reset the connections, which is an option within the file policy, or you'll have to deal with waiting on the browser session to time out because we will not allow the end of file marker to make its way to the endpoint.
Okay. All right. Those are the two we had this round.
Cool. All right. That was a good place. So next in our setup, right? So I ignored or skipped over under the administrative policy portion proxy because I have this section around proxy that we're going to walk through. Don't have to worry about, taking copious notes here. The slides are going to be available for reuse, and you'll be able to pull them up at any time after this session. So earlier I mentioned that there are two things absolutely necessary to get an AMP for Endpoints installation working properly. The first is connectivity. If we can't have connectivity to the cloud, then exclusions don't even matter. There are a couple things I recommend you check out. One, there is a list that we keep updated, forgive me, of all the required ports and URLs for AMP connectivity, and then the FireAmp deployment guide. I'm hoping everyone has, I mentioned this earlier, everyone has an AMP for Endpoints account, because within that account you can go to the help, and there is a section called Supporting Documents, and it has a link to the Deployment Strategy Guide. This guide is always going to have within it the latest URLs and ports for connectivity. So 2 places you can get it, the data you need for where do we need to connect, because you're going to feed this to administrators that are configuring proxies and firewalls and things like that. Oh, I'm sorry, I missed a note here. It was called out on the slide, and I wanted to make sure I reinforced it. As of February 2016, all of the URLs are now living at static IP addresses. This was problematic in the past, right? We used to have to say, okay, just add in everything for sourcefire.com or cisco.com, so that because although we handled the DNS, the IP address lived in spaces, some hosted, right, that were behind IP addresses that were elastic. They would move around. Now we've locked everything in to static IP addresses. The IP addresses won't change, even if some of the DNS changes, as we're dropping some of the old sourcefire.com, making sure everything is moving to cisco.com going forward. The IP addresses are all static. So firewall rules a lot easier now. And then, of course, access rules through proxies a lot easier also. This is just a quick list to grab of the sites. Now, all of these are not necessary for every instance, right? So notice under the Windows Mac connector, there are some things that don't apply. OSX CLAM definitions are not going to be necessary for Windows devices, because the Windows connector does not use CLAM as to where Mac OS X does. The Windows connector uses Tetra. The downloads come from a different place. But this is an up-to-date list, but the most up-to-date list will always live at the URL mentioned on the previous slide. So while this is here for reference, you can always find a more up-to-date list on the previous slide. Incompatibility. AMP for Endpoints does not work with WSA proxy devices without extreme effort. It is the truth of it. It is just because of the way the WSA handles proxy. It is not something that cannot be done, but it is something that takes effort and configuration. Unfortunately, I did not have the ability to pull in WSA configuration details here to get AMP for Endpoints working. It is involved. I have to maybe cover that in a separate session, but we'll make sure we get those caveats called out for you and make that available. What we end up recommending, whether it's WSA or any other proxy, is that you simply just kind of cut us through. Allow us to proceed and make our connection without trying to jump in the middle of it and broker those connections for us. Let us handle what we're doing from end to end, from the connector to the cloud, so that the SSL wrap sessions are not jumbled up when they reach the cloud, and the custom encryption is deemed broken or corrupted, and responses won't come back. If you have an SSL decryptor, absolutely will not work. The communications protocol will not work through an SSL decryption device, so you have to cut us through. This is true for our SSL appliance, Blue Code, name it. It does not matter. If SSL decryption is in the chain of traffic for your endpoints, for connections to the URLs mentioned on the previous slide or the URL list you pull down from our website, you have to cut us through. It's just not going to work without that. And then if I have a proxy and I need to do authentication, NTLM has been spotty on some proxy devices. The way it's been implemented in some cases versus others has just not been clean. And there are times that we see certain checkboxes that we would recommend you enable not do what we expect them to do to return proper responses for access granted. And so what we recommend is that if you have to do authentication, you do some very basic authentication, or again, just turn authentication off for the AMP for endpoints process. How the proxy is set up in the console. So if I have to do a proxy, if I have to use a proxy, this is where I go. Under that general file tab, just under the section for client user interface, is the proxy setup. One, I'm going to have to verify host name, what's the port in use, what's the proxy type, authentication type, usernames. If I have a pack file, that certainly is a way that we can generate, get in. If we've got multiple proxies around an enterprise and the pack file helps us to discover those proxies, I can put that URL to the pack file in, and for endpoints will attempt to pull that down, pull in the information needed and necessary. And as step 5, as it says here, hopefully profit. Hopefully we're able to make the connection. Now, I have a way of kind of testing around proxies, right? Typically, proxies are going to be in the way for port 80, port 443. This cloud communications port is 443 by default. And if I need to test, I can have this set to the old standard 32137, which allows me to communicate, again, on an older protocol port to the AMP cloud that could be something that gets around firewalls or gets through firewalls if punched through, and around proxies because of the traffic type and the port, and potentially allow me to test connectivity. That will help me figure out whether it is actually a proxy hampering my connections or hindering my connections or not. Actually, I'm sorry, there's an out of order here. I've got more on, this is the proper order, I'm sorry. I've got some specifics on testing proxies and tuning against a proxy later. I dropped something else in here to get into the communication. Whitelist, blacklist, and exclusions, because this is all set up, and I'll get into troubleshooting and tuning later. File whitelists. What are they? So whitelist is a configurable feature in AMP, but it is not a whitelist in the typical security application. It's not a technology implementation. What I mean by that is that it is not technology that blacklists everything except that which is explicitly allowed in the whitelist. Let me say that again. My whitelisting capability and functionality is not something that blocks everything except for that which is explicitly declared in my whitelist. It is configurable, but what it is built to do is to give you a guardrail. That guardrails for us are a feature that we make use of either from the cloud or within a whitelist inside of an install that keeps us from convicting custom applications, that keeps us from bothering standard images that may have software that behave in a way that we might consider, malicious. If you have something built in-house and you never want it convicted, you would add those hashes to a whitelist. A whitelist is not used to mitigate performance issues or conflict. That's what exclusions are for. Blacklist, the inverse of a whitelist. It is not an override of the global whitelist. So if I have a global whitelist, as I mentioned earlier, I have guardrails, things like signed files, right? So class 3 signed files that are tied to Microsoft applications that are, there at install, or other, Adobe, Java, name it. There are many applications that provide signed files. We keep those certificates in our global whitelist so that we don't convict them. Blacklisting which is the ability to put in your own custom detections for quarantine against the file, that's not going to override my global whitelist. It will give you a quick way to convict an unclassified or unwanted file, but it will not override my global guardrail. And then file blacklists are also subject to cached dispositions. If you have a file you want to quickly get a custom detection implemented for, but it's something an endpoint has already seen and queried the cloud and has a local cache disposition held, the endpoint connector is going to refer to its local cache and wait till that times out before it uses your custom detection disposition. You have to keep that in mind also. It is not an override for the global whitelist, and it is subject to anything that's already been looked up. I can get around that by deleting the cache files and the cache dispositions on the host, but if they're not deleted, you will still see references to the prior held disposition. So as an example, if I have a PDF that shows up on an endpoint and my cloud says that's unknown, we'll log that as an event that happened. We'll keep it listed as unknown. And even if you go to drop a custom detection for that file and say, this is bad, I want this removed. If you haven't removed the cache and the cache is not timed out, then we're going to continue to use that local disposition rather than use the blacklisted disposition you provide. Thirdly, exclusion list. So blacklist, whitelist, exclusions. I covered exclusions earlier. This is a way to get a little further into it. Exclusion lists, what they are, what they are not. Exclusion lists are a method to prevent both on-access processing and conviction. So processing means I'll ignore it in terms of file I/O. I'll ignore what it's doing. And even if I see that, it could have been malicious, I won't go quarantine it. Because you told me to ignore that directory. Files in it may be malicious, but you told me that directory is off limits to me. I will not go and quarantine anything out of that. I won't convict anything out of that. It is a way to help us live peaceably alongside other security software. But remember, there is an issue that exclusions will not resolve, and that is related to driver altitude. Exclusions are going to be one of the first things we look at when we're dealing with performance issues on an endpoint. If I have a user saying, this is causing my system to run slow, it's bogging down my box, then we're going to start to look at exclusions, how they're built. Are there applications that have high I/O, and we need to possibly consider including them? We need to look at that, and I have some steps on that coming up in a moment. Exclusions are not the same as a whitelist. So even if I've whitelisted a custom application and I won't convict or quarantine it, I'll still watch it. I'll still watch it execute and behave. And it is not a catch-all. This is not the thing to say, okay, I'm just going to, at wide cut and very wide swaths across the environment, build an exclusion so that I get rid of this issue. Because by doing so, you remove our ability to provide security and protection and prevention in that area if you build an exclusion in too wide. So you're going to see from me in just a moment some pointers on how to build exclusions, how to get very specific about the exclusions you build. So to back up those last three slides, when do I use exclusions? Question is, are you having performance or blocking issues? Are there things that are either causing a box to behave slowly and perform slowly, or are we blocking things that we should not be, hindering application use and execution, convicting things that we don't want to? Let's look at exclusions. Are we installing on the server? Exclusions are as important as proxy when installing on a server, be it Active Directory server, IIS, Exchange, does not matter the server type. You've got to make sure you lock in on exclusions, and there's some recommendations about that coming up. If I have in-house apps that I want to make sure are never convicted, whitelist that. Drop it into a whitelist and ensure that we won't. If I have a standard image and I want it as a guardrail, you can provide us a list of hashes for any standard image for your customers, and we will populate, even though I have a global whitelist and guardrail that covers every AMP for Endpoints customer, you can have a very specific guardrail and global and federated whitelist for that customer based upon their standard images. So very quick, something like SSD or HashDeep can run across the system, build hashes, give us the SHA-256 list. We'll populate it on the back end so that it doesn't have to be added one by one. So I've got unwanted files that were not blocked. That's a blacklist. That's a simple custom detection, or as you saw me call it earlier in creating the file policy, quarantine files, right? Quarantine files. Do I want to self-initiate cloud recall, something I want to get off of every system? The blacklist helps to kick that off. Drop a SHA in there, and the process of remediation against that file begins across the environment. If I'm in cleanup mode, if I'm trying to get a system cleaned up after a breach and I'm hunting down files and want to make sure they get quarantined and locked away, those file hashes go into the blacklist. This is a quick explanation on when you use each of those things that we just talked about. Some differences between them. Whitelist, blacklist, exclusions. They're all based on SHA-256. Both whitelist and blacklist are focused on a single or file upload or text file instance, meaning though I can have a list of SHA-256s, how I get them in is going to be either through adding them in singly one by one, giving me the file and letting me build the hash, or submitting a text file that we can then post-process and add in as a full list of hashes to either whitelist or blacklist. Exclusions are built a little differently. They're not focused on the file hash. They're focused on things like file extensions, directory paths. You can use wildcard. We can use wildcards and regexes to help you build. Exclusions are not subject to application blocking or custom detection lists. So if I'm building an exclusion, let's take a moment there, and I want to make sure I get it right. I don't want to catch all. I don't want to wide cut. Don't want to remove security from areas that I need it, but I want to make sure the system performance is held in check and at balance. I've got to understand that, one, there is a processing order even to the way exclusions are built. Extensions and paths are processed faster than wildcards. A wildcard, for those that may not be familiar with the term, would be something like an asterisk. It comes from, regex usage, things like that, and it will declare every character, right? An asterisk is any character that could be represented in this character set. And so that is a lot of work for the AMP for Endpoints connector to have to process for everything that it goes to look at and weigh against an exclusion. So if I want to make sure I'm providing the fastest mechanism for exclusion, go after extensions and paths first. Extensions and paths are very easy, right? Extensions is just a file extension type, .log or .pst. Paths are just that. It is a location to a directory on disk. It ends with a trail. A wildcard, the simplest way is to use an asterisk, but you can speed up your wildcards by anchoring them with an extension. So my example here, right? Use splat or asterisk.db3-journal versus asterisk.db asterisk. The second instance in that particular use case, I don't know if you can see my mouse moving or not, is a slower exclusion lookup than the anchor of the file extension. I would still have the same net effect of ignoring all db3-journal file or files with the db3-journal extension, the same net effect as the wildcard, but it would work a lot faster. Typical places that we see wildcards used, though, are going to be across, file names, but even multiple drive letters. This example here, right? If I don't know where any particular subdir that points off to a log, archive of log files lives on a server install, but I know it's under Windows, maybe somewhere else for these log files, then I can just add in asterisk on the front end, asterisk in the middle, and use the anchor of .log to give me a little bit of a speed up. The last thing that helps is CCITL. CCITL allows you to use a very common way to express path locations and identifications of such on disk. So troubleshooting. Let's move forward into that. Where are we on time?
We're about an hour and a half in, so we have roughly an hour and a half left.
Okay. Any questions in queue for us or no?
There are a couple. Some of them might be answered in the troubleshooting, but I'll go ahead and run through them really quickly. The first one was you mentioned a tool to generate the hash. That's not built into the AMP console, correct? You would need to have a third-party tool to generate that hash, or is it actually in the tool?
Actually, if you upload a file to us, we will build the hash for you. If
Okay.
if you cannot upload the file to us, not allowed, or just not able to, if you need to build a hash locally on a system, you'd have to download something like Hashdeep, which has tools for like generating SHA-256s in it.
Okay. All right. The other one was Cloud Web Security compatibility with AMP for endpoints. Are there any issues, known issues? Does it work okay?
CSA, I'm sorry, Cloud Security, got you.
CWS.
The CWS,
Right.
I'm sorry, CWS. Does it, so CWS is a proxy itself. It will interrupt the connections and send them to towers that live in the cloud. And baked into CWS is the ability to run AMP there because it will interfere with the traffic we need to be able to send to our AMP cloud. So if you have CWS and you still want AMP for the endpoints that are actually running CWS, you're going to want to consider CWS Premium for those particular endpoints.
Okay. And the final one was, and I'll just ask the question. So Andre had an installation there in his own deployment where he installed AMP on 12 machines running Windows 7, and 8 of them started freezing after reboot. Is that something that you guys have seen in the past? Is there any place he could look to troubleshoot that, or are there any troubleshooting guides posted out there that he could look through?
So the install log is going to be key. There's an install log that gets generated in the Windows temp directory at install that could help us to figure out, one, whether everything registered properly and was settled on disk properly, whether we noticed any particular conflicts at the time of install. But generally speaking, Windows 7 installs have gone very, very well. But I would wonder if we kind of follow the process of, getting a ticket open for Tier 3 to jump into to look at, even if it's is this a Cisco employee or is it a partner? Do you know?
It's a partner, yes, partner.
Okay, so I would say let's get a TAC ticket open and let us get at the install log and any other info that could help point at the issue. Not to say that I have not seen issues at install, I have, but it's typically been related to existing software where there was a conflict. But if we can get the install log, that'll help us point at the issue.
Right. I can see where it could be some other AV software might have had a little bit of a conflict as it was installing.
Mm-hmm.
Okay. All right. Those were the questions for this round.
Okay, cool. All right, so Troubleshooting. Number one is always the proxy. That's kind of the way it's kind of the point we've arrived at in understanding problems in communications. It's generally the proxy that has some issues with the way the communications protocol is built. So even though our communications are wrapped in SSL, there is custom encryption under that. And if at any time the proxy thinks it needs to interfere with the SSL comms and goes to look at the lower traffic, it's going to have real problems with that traffic once it unwraps it, and typically just drop it. It will throw it to the floor. Number two, as I mentioned just earlier, the installation log. Gathering insight from what happened at install is key. It is written by default. It's not something that needs to be generated. We write an installation log for every connector install on every host in its temp directory at install time, so that we can always pull that back and begin to use that to gain insight into what happened when we were installing and did registration fail when we tried to register with the cloud and things like that. Lastly, contact TAC when all else fails. So the normal stuff are the things I'm getting ready to show you. If you've done those things and I still don't have resolve, there's still no issue, contact TAC. I can't kind of reinforce that enough. Although we're, all engineers on this call and we like to try and hunt down and troubleshoot and fix ourselves, there are going to be some times when we need to pull in folks from our Tier 3 support organization, and they are glad to help in deployments, figuring out any issues that may have crept up. So don't fail to contact TAC if needed. So verifying connectivity via the proxy. Since we do kind of point at the proxy saying it's bothering our communications, there's some things that we can do to verify connectivity via the proxy. When I have a connector installed, go back to your console policy, the cloud console, the AMP console, change the heartbeat. Remember, if you haven't done so, set it down to 15 minutes like I recommend, make that change, and update your policy to reflect this. On the endpoint, you're going to need to stop and start the AMP process, the AMP service. And so this is the command to do so. Get administrator level access at a command prompt. And this just run net stop immunet protect, wait, and then net start immunet protect. This will halt and then kick up again my AMP for endpoints processes. Once the connector is stopped and started, it should begin to phone back in and pull in an updated policy with the updated data. If connectivity has, if we have successful connections and a successful policy pull-in, you'll be able to pull up a local file under your AMP for endpoints install directory. This is the default program file, source file, FireAmp. You'll be able to find a file called policy.xml. Open this up in a text editor and hunt for a serial number. The serial number should match the serial number on the policy you just edited. So you have to make some material change, as I mentioned, to like heartbeat interval or some other component that writes a new serial number. You can't just change an exclusion, or you can't just change a blacklist or a whitelist. You have to make a policy change to get a new serial number. And if the serial number in policy.xml matches to the serial number of your policy in the cloud console after a few minutes, then we've got good connectivity. If they don't match, and I have seen it take up to about 5 minutes for this to resolve, if they do not match, then we've got a connectivity issue, and there are a few other things that we're going to want to do to verify connectivity through the proxy. So let's look at the proxy settings in the policy XML. Just as I mentioned earlier, right, in the policy, that's where you would declare them. Let's just make sure that the policy was injected properly into the redistributable installer, and we do that by digging a little further into that policy.xml file. If there is no proxy configured, this is what you'll see under the proxy section, this first graphic here, where you will see us talking with no local resolve host and no pack location, no off type, right? None of this will have any data if there is no proxy configured. If I have a proxy configured for a pack file, you'll see a pack location. First thing to check, from this endpoint, can I reach that pack across the network? Pull up a web browser, some other way to test just straight connectivity through to the pack file location. Easy thing to do. One, check and see if that policy injected properly into the redistributable installer. And if we've got a pack location as a part of the proxy setting, let me just browse to that from the local host and see if it pulls down anything. If I have a pack file and basic authentication, right? Not only will I have a pack location, but I'll have some information around password and server information tied in there. So you'll start to see port and proxy type and things of that nature baked into the proxy, the policy.xml config under the proxy subsetting. So if that does work within the policy.xml, I've got all the things that I declared on the Cloud Console in the policy.xml. They line up looking at it one by one. I can then test from the command line. You're going to need curl installed on your systems to do this. I think it comes by default on Mac, certainly on Linux. On Windows, you're going to have to go get it. But curl can help you test and troubleshoot. So again, let's get our policy number. If we want to bump up another policy serial number, we can make a change, a material change to the policy in some way and save it, see that there is now a new policy number. Then we can then use a hex calculator to get information that we're going to need. So there's going to be a long policy number that we'll need to look for that we can easily calculate. Again, you need a hex calculator to do this. Most systems will have something like this under their calc application. Look at the business UUID from the policy.xml file. And there are going to be percent signs that we'll replace with hashes as a part of our test. These are the initial setup steps to get ready to test with curl. Get curl, make sure we've got an updated policy serial number in the console that we can look at, make sure we can get a hex calculator out on this or pull it up on the system, calculate a long policy number, pull the UUID out of the policy.xml file, and we're going to replace dashes with percent signs. This is the command to actually try and pull down the policy file using curl. So different website, right? Not one you've typically seen in all of the other declarations for access, but we're going to go straight to policy.amp.cisco.com. We have to have that business UUID that we pulled out of the policy.xml file. We're going to need the long policy number as calculated with our hex calculator. And then our output, if we're successful, should be a file named policy.txt. What this will help us figure out is full communication through to the cloud from the host, eliminating or either pulling in or eliminating AMP for endpoints as a possible issue in the comms path. This points us at the host can reach it, and I've got another application that can pull down the policy.xml file. What else are we having issues with? Let's look at the output. So our curl commands will give us pretty extensive output if we use the verbose flag as a part of our command set. The main thing, make sure we're talking to Cisco and not a proxy, because pointing back to the earlier issue of dealing with SSL, if it's just a plain old proxy not bothering SSL traffic, we can probably work into that without an issue. There are issues around NTLM authentication, as I mentioned earlier. Just take it down to a very basic type, if possible, for authentication. But I need to make sure my comms are cut through to the cloud and SSL is not being decrypted and bothered for traffic communications. In any scenario, proxy or a dedicated SSL decryption device, they will both cause failures. At success, this is what you should see. Output that says we are connected to policy.amp.cisco.com at this static IP address. Again, this IP address is now static. And then information about the actual SSL connection. And then the actual host communicated with, not a proxy, but policy.amp.cisco.com. All right, so that's a quick troubleshoot on connectivity and the typical issues we see. Let's say we've gotten past troubleshooting connectivity, but we still have to deal with our other issue of exclusions. I'm installing on servers now. I'm past the client. I'm past the AV that lives there and building exclusions for them so that we can coincide and live well. Now I need to go a little further. Tuning and troubleshooting tuning. Exclusions are going to be the key thing, back to my earlier slide. Not blacklist, not whitelist, of course, exclusions. There are a couple of ways you can handle exclusions and getting at the data that helps you to build exclusions properly. One is you can download a small executable, SQLite, and this is the more difficult way, but I do have the command set in there. And when I say difficult, it's just not as easy and pretty as the script that we've made available. It's not hard to run the SQLite commands to get at data directly from the history files on a connector. But I'll give you the way to do both, and you'll have access to both as an option. So again, back to exclusions. I'm using to ignore file or path, which I don't want to be considered malware, but it might be something that's updated a lot. Transaction files, log files, database files, PSTs, as I've mentioned. Again, also used to ignore existing AV, conflicts with other security software. I do have a link to best practices for exclusions here. That link gives you an exhaustive a list of exclusions to consider based upon types, based upon the types of applications we are going to have to worry about if you're installing on servers, right? If it is a database server, what type of database is it? If it's MS SQL, what are the things we're going to be ignoring there? The advice at this link comes from Microsoft. So Microsoft has a list of exclusions they recommend every vendor that deals with file I/O and heavy transactions, AV and the like, that they would ignore. So we've taken those and packaged them up into the most commonly used and seen notations and make them available for you at that site. It's kept updated there. I did not include it in this presentation because it is an exhaustive list, and I did not want the age of an included list to come back later and be problematic. Focus on what we made available there under the support docs. So if I'm using the SQLite EXE, what do I need to do? Well, there's a history.db file that lives under the FireAmp or AMP for Endpoints install. Excuse me, I keep saying FireAmp. It's just an older name for the same product. But the AMP for Endpoints install alongside policy.xml, there's a history.db file that gives us transaction data, right? So all the file I/O we see and how frequently we've had to see, we've seen a particular file name, we keep that in the history, no matter what we've done with it. We still keep a history of having seen that file through our file I/O. And if I can grab that file, I can either locally on the connector, on the system where the connector is installed, or a separate system, run this command. So I enter into the SQLite exe by just running the command against the history database. It loads it. Say, okay, headers on. I want to see the headers for the tables that I'm about to run through, so I know the names across those tables. And then select for file name and count against file name from the history table, and we're going to group them together by file name so that it begins to order it for me, and we see the most frequently seen at the top, and then it goes in descending order from there. As we order this against the count, it begins to just give us lines out of that table in history DB. Notice that the first one, a file named C Windows Task User Feed Synchronization, and then a GUID.job, has been seen 1,700 times in the entire list of entire history. Documents and settings, administrator, local settings, etc., read on through, has been seen 341 times. And then the next one down, seen 222 times. This would continue on and on throughout the entire history.db. So until we've reached, all of the files seen in history, and give you a count against every file seen for I/O. What this then points to now is I might be able to take some of these things and consider exclusions that could help me in terms of performance. Internet Explorer suggested sites.feed.ms, that might be something I consider removing. So how do I build that exclusion? Well, I don't know where it's always going to live. It's a documents and settings thing, but it's going to always be under the Windows base directory. So how do I use that? How do I get there? By using Microsoft CCITL notation, I can easily get to CCITL_Windows, no matter where this may be, and get to the subdir task file extension, and then a wildcard for any name, Internet Explorer suggested feeds, or any other particular name that might come up. And then my file extension, feed-ms. So I've got an anchor to make it fast with the file extension. I've got a wildcard that finds any file name before the extension. And I have a CCITL notation that helps me to find the directory I'm concerned about, no matter where it is on the Windows install. That's the SQLite way to get at it. Manual, but we also have a tool called tune.sh. How do I use tune.sh? Well, you can download it. I provided a link to it a couple slides back. You download tune.sh, and you need a system that has some kind of, Unix, Linux type tools built in. So you're going to use, most folks typically have an install of Kali available to them in a virtual machine or something like that. You're going to use, you can use it on a Mac by default, or if you're, restricted to Windows only, you can use Cygwin for the tools there. For tune.sh, we're going to need to point it at the proper .db file again. So this is based off of the thought that I have taken the file off of the Windows host, that the history.db file that was there, and I'm now using that history.db file on some other host. These commands are executed based on that premise and thought. Tune.sh against the DB, and then I'm going to use a Python script called bar_chart just to give me some pretty output, and a file name for the output of the post-processed Python data. When I review the output, this file name of filename.out, or whatever I've chosen to name it, the more bars, the more times that file's been touched. This coincides with the number you saw on the previous slide at the end of the select against the history.db table data. Now, the order is different. It goes, instead of most frequently seen and sorting in descending order on the command I gave you, tune.sh starts at the lowest count and gives you the number in ascending order. And rather than have to hunt through numbers, because this could be quite extensive based on the size of the history file, it is the bars that present insight and data so that you can quickly get your eye on the most frequently seen files. And just as seen on the previous slide, this begins to point at possible places to consider for exclusions to build in where I want to avoid processing files so that I'm ensuring performance is kept in balance and in check, along with security as needed. So two ways: SQLite directly against the history.db, or get the history.db off the system and use tune.sh against Python's bar chart module. This is pretty. It gives you an option to present something to a customer and help them understand why it is we're talking about excluding a certain directory or a certain file, because the frequency seen, and then using that to also talk about the security implications of adding such a file or directory to the exclusion list. If we keep going down, right, I can take file name.out and quickly get to the top of those files as most frequently seen. And the ones that have top as an implication are the ones I want to consider. In particular, it's top file where I want to start. Top source would be associated to actions seen, and that could be data around connections out, DFC, things like that. Exclusions are not really going to get you where you want to be to tune against that. You're going to want to deal with top files and drop those into exclusions. Top source isn't really going to give you the weight of benefit that excluding top files would. So then add them in. Use the notions that we've mentioned, right? Wildcards that are anchored with a file extension. If I don't know where a directory is going to live, the other earlier example, right? All users or administrator, and that may be anywhere. Maybe I need to use CCITL, things like that. We save it. Now, saving an exclusion does not initiate a file policy update. I'm sorry, an for endpoints policy update. You have to go back to the file policy and make some small change. The recommendations are maybe tweak a cache value, turn it down or up, maybe schedule a flash scan, or change the connector protection password. But for now, you have to change a policy item to get it to pull in.
Hey, Eric, I think we may have lost your voice.
Can you hear me?
Yep, there you are. You faded out right at the end of that last slide.
Okay, I'm sorry. So when you are adding items to exclusions, even though you click save, it is not enough, because clicking save on an exclusion set does not cause the policy serial number to change, even for policies that reference that exclusion set. You have to go into the policy, make some change. As I mentioned, either cache values, tweak it there, which is a good place to go. Maybe schedule a flash scan, or tweak the connector protection password. It has to be something that will generate a new policy serial number in the policies that reference the exclusion set you just updated. Once you've done that and you have a new serial number, the host as a part of their heartbeat interval will check in, ask the cloud, do you have an update for me? Has my configuration changed? Has the policy been updated? If the answer comes back yes, it will pull in all of the new data, the policy changes, and the new exclusion sets, and go to work based upon the new data. You can hurry this process with the steps I mentioned earlier by stopping the connector services on a host with an administrator console, waiting a few minutes, and then restarting those services. That will hasten checking into the cloud and seeing if a policy update has occurred. At start, it will check the cloud to see if the current policy in the cloud is the same as the policy locally. And again, if the serial numbers change, then I'm able to get that new policy down to the system and allow it to continue to run. So that's troubleshooting on exclusions and on proxy settings. And those are the most common areas that have issues around deployment. Back to my earlier statement, if you're going to deploy AMP for endpoints, after you've done all the things around gathering, operating systems we're going to install too, and know that we're going to do both clients and servers, and we've qualified, that we're not just in a detection race, we're actually going to be showing great AMP for endpoints value. The question then becomes, do I have connectivity, and do I know what I need to build for exclusions to ensure performance? Connectivity actually helps me get installed and work. Exclusions help me make sure I'm performing well and not hindering or hampering performance of the box or other applications on the same system we're residing on. That kind of brings what I had today to a close, and back to the whole picture, right? AMP is everywhere, and we are able to deploy both network and endpoint components in ways that are delivering effective security in open and easy ways. If you have questions, certainly begin to put them in the Q&A now. If you want to ask them live, we have until 4 o'clock. I can take them live. You can raise your hand, and Ernest can unmute anyone so that we're not dealing with everyone coming off of mute at the same time. But that's what I wanted to make sure we got through today. So let's get into questions if we have them.
All right. So we actually had one come up just a moment ago. Ryan asked, why not simply add a button to increment the policy number to force the update for events like adding exclusions where the customer is confused as to why it's not being pushed?
Yep, it's a feature request in, just don't know when it's going to be delivered.
Gotcha. Okay. All right, so that's it from the Q&A panel. I tell you what, if you have another question you want to throw it into the Q&A panel, we can do that. You can also raise your hand, and I will scroll back and forth to see if anyone has done that. If you want to ask a question live of Eric, just go ahead and raise your hand. I will see that, and I will unmute you. Let's see. I don't see anything as of yet. We can give it a few minutes just to verify. Roy asked a question. Can you put the links to the deployment guide? That slide up again.
I can. This whole presentation will be available right after, but I can. Give me just a second.
Yep. Yeah. I'll basically what I'll have to do is get the request submitted. It will be in the Sales Connect, but I'll have a link through the security community. So just keep an eye out on the link. I did put those links in the chat, the front page for the security community, and then also the link for the TechTalk section within the community. So just keep an eye out on that. Probably within the next week or two, we should get those posted up. It does take a little bit of time to get the video converted to MP4 and then posted up to Sales Connect. So as soon as that does happen, we will get that up there for you guys. while Eric's doing that, actually, Eric Roy said he can wait for that, so no worries there.
Okay. Okay. Good enough.
All right. Any other live questions?
I tried to push out a poll question. Not sure if it went out or not. But I'd like to know whether a session on ESA plus AMP deployment would be useful to folks on the call.
If you want to throw that into the chat, just put a quick response, yes or no. If you don't see the poll, just put a quick yes or no in the chat, and we can sort of take a look at that. And you can do it to the host and panelists. Got a couple yeses already, so.
Okay, cool. Good enough. Thought so. So what I'd like to cover with that is not just the AMP piece, but the threat grid piece. There are issues around limits and things like that. We want to make sure we get good field understanding against that. So I'll work on that, and we'll try to get a date with Ernest to get something like that set up for you guys also.
Absolutely, absolutely. We've got a really busy Tech Talk schedule, but we can definitely get that on the calendar and get something like that posted out. All right. Any other live questions? Go ahead.
I have one. Yep, I got one back to the folks. What about, so I didn't even cover at a deep level private cloud and threat grid on premise. Something like that would be useful also to get into deploying AMP for private cloud instances and coupling that with threat grid on premise.
I got a yes, please, exclamation point.
Okay, good enough. We'll get it on the list.
All right, and also you will get a survey after you close down the session. If there's any feedback you want to give in there as well, I'll pull that report afterwards, and I can give that feedback back to Eric. So if you want to throw some comments in about future session, maybe any other questions from this session, please do take a few moments and fill out that survey. All right, we're about 9 after the hour. We'll give it another minute or so. I don't see any hands raised as of yet. If we don't see anything by 10 after, we will go ahead and shut things down. I'll scan through the Q&A one last time as well. There's nothing new in the Q&A, nothing new in the chat. So I would say we are probably good at this point. All right, with that,
thanks, Ernest.
I will go ahead and close out the session. Eric, thank you very much for both of these sessions. I know that was a lot of talking for you to do, and appreciate everyone's willingness to stay on the call. This is a lot of information to take in. Again, the session and the recording and the slides will be posted within a couple weeks, so just stay tuned with that if you want to pull anything back up and search back through. But thank you for your time today, and looking forward to seeing you all next time. Thanks, everyone.